All right, so moving out to field stars within the Milky Way. Our next project was, again, another Maui team, Michael Stevens, entry 11th grade, and Jordan Vaughn, entry 9th grade. Are you guys, I know you're a second-time returner. Are you first time? First time, okay, great. Excellent, welcome. And their mentor is Ari Heinze, who's sitting right back there, and he helped them with Atlas data for this project. So, you guys, take it away.
So, hello everyone, I'm Michael Stevens.
And I'm Jordan Vaughn.
And this is our project on analyzing variable stars.
So, what is a variable star? Well, a variable star is a star who has a magnitude that varies over a specific amount of time.
So, our goal is to discover any unknown variable stars. And we did this by taking the right ascension and declination of stars in our data and inputting them in the AAVSO catalogs. And then once we would go ahead and characterize these stars by inputting the data in our graphs, and just by doing all of this, we are also testing the completeness of current catalogs, such as I said earlier, like the AAVSO catalogs.
So, how do we analyze a variable star? Well, when we analyze a variable star, we look for specific patterns in a light curve. But sometimes those light curves vary, giving us interesting data. This right here is an eclipsing binary, which we put that as an example to a regular sine wave to show how the data and light curves can vary.
So this is the eclipsing binary we discovered. Well, we thought we discovered. Anyways, I'll get to that. So an eclipsing binary is essentially a pair of stars that are parallel to our point of view. So not every pair of stars in the sky would be considered eclipsing, because, for example, if we have a binary pair perpendicular to us, the two stars will not cancel out each other's brightness, as you can see here in this graph. It is flat, and then once one of the stars goes behind the other, the brightness drops drastically before coming back up as the star moves out of the other star's shadow. So I'll talk about how we thought we discovered this one, and this was a bit, well, it was just, anyways. I'm sorry, it's hard to speak. Anyways. We thought we discovered this one because when we looked this up in the AAVSO catalogs, it showed that that there was no star in this area when we took the right ascension and the declination of the star. There was no star in the area. So, but it appears that the data was off by 2.5 arc seconds. So, because when we changed the radius to 5 arc seconds, we found that there was a star in this area.
So, as you know, there's always the trouble with the data. So, we were given vast quantities of numbers from Atlas, and it made us more prone to have errors. So, when we were creating the equations, a lot of things happened. Also, sometimes the software didn't want to cooperate, so we would input the phases and the magnitude, but the graphing would turn out to do this improbable thing that could never happen. Yeah, small mistakes are fun.
So yeah, we would if the data was incorrect, we would not get a pattern. I'm just putting that out there. You just wouldn't. So if the data was ever incorrect, you'd only get something like this.
So this is all of our data that we collected. We did a lot of variable stars, each light curve being more unique than the next one. And yeah, we made a lot of discoveries, about 7 of them. It's pretty cool.
Okay, so So we did actually make one. Well, we think it was a discovery, but so we found what appears to be a previously unknown Cepheid. We know this because, or we think this because it has a period of 12 days, and as you can see from our light curve, it has a very steep incline and a shallow decline, which kind of which implies a Cepheid type variable. We think that it might be either 142,000 light years or 68,000 light years away, depending on whether it is a classical or a type 2 Cepheid variable. A type 2 is cooler, while a classical is brighter. So, and because our math depends on the brightness of the star to find its distance, we have two distances. And the interesting thing about these distances is that our galaxy is only 100,000 light years across. So this means that this star is outside of our galaxy. Actually, regardless of which type of Cepheid variable, it is outside of our galaxy because of the direction we're pointed at. But the 142,000 would be special because that's even beyond the halo. So it could be even possible to say that this could be even a hypervelocity Cepheid, but we still need more data. And so we also discovered what is an RR Lyrae type variable, and this is similar to a Cepheid, but it is a lot dimmer because it varies much faster. So the sawtooth pattern is is what you would normally see in a RR type Lyrae, an RR Lyrae type variable, and yeah, I guess that's all I have to say about that. Thank you.
Overall, I think that this project went pretty well since we discovered multiple variable stars and a possible Cepheid star. Cepheid. We also found that we discovered all these stars quite interesting because the existing catalogs are surprisingly incomplete. It also comes as a shocker because these variable stars are really bright. Judging by how bright they are, you would have thought they would have already been discovered by now, which shows that there is so much more about a universe that we just don't know yet.
And so we would like to thank Ari Heinze, our mentor, and to all the affiliates of the High Star program, because without them, this presentation would not be possible. So thank you.
Roberto, right there.
What is the galactic latitude of the Cepheid?
What is the?
I'm sorry, say that again?
The galactic latitude of the Cepheid.
The latitude?
Yeah.
Repeat the question, please.
Oh, I'm afraid I don't know that.
Do you know how close? I guess another way to put it is, do you know how close it is to the plane of the Milky Way?
Not close at all. It's almost, you could almost say it's perpendicular.
Okay.
Perpendicular to the Milky Way.
That's where your search field is, right, for Atlas? Is that right?
This
High
field
galactic
was
latitude.
at high galactic
High
latitude,
galactic
way out
latitude.
in the plane.
The answer is high, Roberto. It's high. Good. Questions? Okay, right here.
What did you decide on possibly naming your star?
Okay, so this was quite interesting. Okay, so there are two possibilities. We were going to name it, we're either going to name it Morden for the Ring of Order, yeah, or Jekyll as in Jekyll and Hyde, because it's kind of interesting, really. It has two different sides.
Okay. Thank you. Nice quick answer. Maybe one last question. Yeah, let's go with Jeff. If you want to say this.
How did you discover your declination was off by 2.5 arc seconds?
Okay, so.
So I'm actually the one who discovered that star. So when we searched it in a radius of 2 arc seconds. Yeah, that's awesome. We searched it in 2 arc seconds, and nothing showed up. So we're like, all right, yeah. But then when I searched it again, I accidentally put it in as 5 arc seconds, and then it showed up, and I'm like, wait, this doesn't make any sense because it
Search
hasn't
results,
showed up before. Yeah. And then I had my mentor come over and check it because he also checked it before to see if it was undiscovered. So we were both in for a little surprise when you're not original. That's nice.
It happens. Okay, let's thank our speakers one more time.